We are now working with the 7th grade acids bases topic. In this topic, we are right now working or about to work with reaction of acids with metals. Before we do that experiment, I have a question. Like, I think most of us would have seen pickles at our houses or the pickles that we purchase outside. Have you ever seen the jar used for pickles to be a metal? Try to recollect right from your childhood. When I was a kid, I saw all the pickles stored in a ceramic jar. Ceramic jars are nothing but jars made with mud or clay, and they are coated with a glossy substance. So clay was used for storing the pickles. And nowadays, wherever we see pickles, we actually see pickles like stored in glass. So please think, why can't we store pickles in metal containers? Metal containers are available everywhere. Okay. The reason for that you will understand in some time. Pickles are essentially acidic substances. In a way, they have acidic or acid nature. And we are going to see what happens if you store such acids in metals. Will they react or will they not react? If they react, then metals are not suitable for storing the pickles or acids. If they do not react, then well and good, we can actually store pickles inside metal containers. So for that, what we are going to use are, I'm going to use hydrochloric acid. Hydrochloric acid. I'm not using concentrated version, I'm using dilute version. So its formula is HCl. So I have my dilute hydrochloric acid over here. Then I'll use two metals. First I will use zinc, Zinc, the symbol is Zn, and another metal is magnesium. Right? So the two metals that we'll be using are zinc, these are zinc granules, and this is magnesium ripple. Now, these are the consumables, these are the chemicals anyway. Now, what are the tools I am going to use? I am going to use a test tube holder. I'm sorry, this is a test tube of course, and this is the test tube holder. And along with this, we will also use a rubber cork. The reason for using rubber cork is if I use concentrated acid instead of dilute acid, whatever gases that would release would come with great speeds and all. But since we are using dilute acids, everything will be slow. The gas production or the reaction rate, everything will be slow. So that is the reason we have to use a rubber cork to store whatever chemical is created inside. Okay. So that's about this rubber cork related information. To test for the gas, whichever gas is created, I am going to use a burning matchstick along with an incense stick. So I have incense stick over there. And to protect myself, I am going to use two things. We are going to do or complete the experiment by putting the materials inside a tray. When we do it inside such a tray, we avoid spillage of any chemicals. And second thing, I will be wearing gloves during the experiment. This will protect myself from any harm that could happen. So now, before we move on, let's see the reaction part of it. Hydrochloric acid formula is HCl and Zn is the zinc. Same way, hydrochloric acid plus magnesium. 7th class kids would not know these symbols, but you can try to plant the seeds of these chemical formulas and everything at this early age. So when they go to 10th class, it might not seem to be like the first time they are observing all this. Now, whenever hydrochloric acid and zinc react, we create a salt called zinc chloride, ZnCl2, and a gas is created, that is hydrogen gas. Same way, HCl and magnesium, we get something called magnesium chloride and hydrogen gas. Both these experiments, they release lot of heat. So that's why I am placing plus Q. Q indicates release of energy. Okay, so it's on the product side. Now, since we have the reaction and everything, let's complete the experiment. By the way, these are not balanced. This is your work. Try to balance them. Here we have one zinc, I have one zinc. I have one hydrogen, I have two hydrogens. I have one chlorine, I have two chlorines. So obviously this is not a balanced chemical reaction. You can do it yourself. It's very simple to balance. Okay. Now let's go ahead and complete the experiment part of this experiment. This is the zinc granule. It has sharp edges. So never drop them from height. You have to place the test tube at an angle and let the zinc slide underneath. So that will give you better results. Not the results per se, but it would not cause any cracks to the test tube. So you and the test tube, everything will be protected. Next, this is my dilute hydrochloric acid. I'm going to pour a little inside it. Then I will close this assembly with a rubber cork. So I don't want to apply too much of pressure. That will create internal pressure and there is a good chance the glass might blast too. So don't keep it too loose, the gas might escape. So what I generally do is place the rubber cork loosely and tap twice. So this is what I do. Now I want you to see this very closely. I'm fixing it with a test tube holder. And now please check this. Do you see bubbles inside the test tube? You can see lot of tiny bubbles that are created. So here zinc is relatively slow to react. But if I add much more reactive metal like magnesium, then the reaction would speed up and we would get faster results. To speed up the reaction, we have many options. One, I can constantly keep it shaking. That would speed up the reaction to a little degree. But if I add or if I heat this entire solution, let's say I'm heating it with a burner, then the reaction would be super fast. Other way is to use a concentrated acid instead of a dilute acid. That is not an option because I always want students to do the experiment. So teachers can use concentrated version, but students have to use dilute version. Now the last option for me is not just zinc, some other very reactive metal. In fact, I have magnesium for that purpose. So you can observe clearly as soon as I add magnesium, there is a good chance the reaction might speed up aggressively. So before that, before adding magnesium, I want to get ready with my matchstick. I'm removing my gloves for now. When students are working in groups, they'll have ample opportunity to do it safely while enjoying the experiment, because one person in the group might be handling these materials, another person might handle the matchbox and incense stick. In textbook, what I generally see is only the matchstick, but we are using an incense stick because incense sticks are longer. Our hands need not be on top of the test tube. And always remember, ask your students or yourself to never put it at an angle or vertical. That would cause the gas to burn your hands too. Your fingers might be on top of the test tube at that time. So always I prefer my students using it horizontally at the mouth of the test tube. Now I'll remove the rubber cork and see if there is any change. If I see a change or if I do not see a change, I'll immediately add the magnesium ribbon. So my magnesium ribbon is ready over here. So this is my magnesium ribbon. First, without magnesium ribbon, I think you already heard the reaction. You heard a pop sound. Now I want to add the magnesium ribbon. This is the magnesium ribbon. Observe how fast the reaction is. Already the rubber cork got pushed out. See, it's not even getting stable over there. I'll just rise it. See the reaction? It's extremely aggressive. Now, when there is too much of gas, more than required, there's a good chance you might not hear the pop sound. You might only see the flames. But let's give it a try. You saw that, right? There was very little pop sound, and you might have seen flame inside like something very close to a candle flame inside, because enormous amount of gas is released with magnesium. Only with correct amount of gas you hear the pop sound. Let's try one more time before we stop this, right? Now carefully get rid of the incense stick red bud. Make sure it is not at a location where people will stamp on it. Put it away at far off location. Now the experiment is done. Another thing the students have to observe is they have to touch the outside of the test tube. And it is actually hot, not even warm, it is hot. If it was zinc, only zinc, it would have been warm. Since magnesium is very fast in reaction, it is actually extremely hot now. Now, we are done with the experiment. The observations of this experiment is, we saw bubbles inside the test tube when we mixed the metal and acid. When we placed a burning incense stick, did you hear any sound? Yes. What type of sound is it? It's the pop sound. And I don't know if you have observed or not, one of the scenarios, when you heard the pop sound, the flame was also put off at the same time. The flame, whatever flame you had at the incense stick, it got put off. This shows that whatever gas that was burning, it was even able to put off the flame while giving pop sound. This is the classic example or classic case of hydrogen being released. Hydrogen gas, whenever it burns, it even puts off the flame because it takes away all the oxygen. Hydrogen burns with oxygen. So it removes all the oxygen in the environment. Since there is no more oxygen, there's a good chance the flame will be put off. So that's about the experiment. Now I want you to observe how to get rid of these chemicals in a safe way. So for that, I'm taking a different beaker. So I have this beaker. You can have another dustbin. Pour away all those chemicals. Take it away from the students and clean it yourself. Do not give students to clean them because this is acid. There might be acid residue and kids might touch it accidentally. So that's with the experiment. Now let's go ahead and discuss the conclusions of this experiment. So we have completed the experiment. I hope you have enjoyed it. You heard pop sound. So that proves that this is hydrogen gas. The gas that came out of the reaction is hydrogen gas. Now let's conclude it. Instead of HCl, I can use lemon juice, I can use sulfuric acid. I'm using hydrochloric acid because I can make it dilute and I'll get good results. Lemon juice, it's not strong enough. You might see the result with magnesium, but with zinc it would be very, very tough. So instead of HCl, I'm writing this as acid. So acid react with metals to produce, what is zinc chloride and magnesium chloride? These are salt solutions. Salt solution plus hydrogen gas. Hydrogen gas. And lastly, this Q indicates it is exothermic reaction. Energy is released. So some energy is released. How do I know energy is released? Try to recollect. I touched the test tube and I was able to feel the heat. That means the contents of the test tube were releasing energy. So that is what is this energy. Now I think you understood why we cannot store pickles in metal containers, but you can use ceramic, that means mud-based containers or glass containers. The reason is mud and glass will not react with acids, but metal containers will react with acids, and whenever they react, they'll create hydrogen gas, and that gas could even blast that metal container and explode. You already know hydrogen is combustible. A tiny spark near the container could create a small blast or a big blast. Now, it's not just the storage of pickles. You might also have heard this. Maybe you heard your mother telling or someone else, relatives talking about this. They always tell that never store curries in aluminum vessels. So in Telugu we say ratinni. So ratinni ginnelu. Okay, aluminum vessels are very good metals in the sense that they can react very fast with acids. And most of the curries have tomatoes or other things like tamarind and all. So that those are acidic in nature. When you store these curries in aluminum vessels or aluminium vessels, they will react, they'll create new salts which could be dangerous for us. So that is the reason you should not store it. And you might also have heard another thing. Never store or never imagine I have this water in this. If I use lemon and squeeze that lemon, I'll have lemon water inside copper. You should never drink that lemon water because this copper will react with lemon and lemon juice or lemon water, and that could be very, very harmful. It could cause a lot of health issues. So never try to mix acids with metals and consume it. With that, we are closing this topic. Thank you for listening to me.